Alright, ladies and gentlemen, this is Quiz 2 Review Packet. We'll go through the problem step by step, and hopefully this get a nice full understanding of the material here. So, in our first problem we have 8 equals a minus 12. Our goal is to get a all by itself. So what we got to do, we got to add 12 to both sides of the equal sign. So this is our given. 8 equals a minus 12. We add 12 to both sides of that equal sign. And we get a solution of a equals 20, where 20 equals a. That's the answer to number 1. Problem number 2. We have 4 equals v divided by 13. Right here on the side here, that's what's given to us. So what we need to do, we need to multiply by 13 to both sides of the equation. And then we get v equals 52, and that's our solution. Problem number 3. We have to solve each equation. Remember to check for extraneous solutions. We have the square root of 18 minus 2n plus 9 equals 15. That's our given. We have to first subtract 9 from both sides of the equal sign. So we get the square root, the radical, 18 minus 2n all by itself, and it's equal to 24. We then square both sides of the equal sign. And when we get that, we get 18 minus 2n equals 576. Because 24 squared is 576. We then subtract 18 from both sides of the equal sign, and we get negative 2n equals 558. We divide by negative 2 to both sides of the equation, and we get n equals negative 279, and that is our solution. Here's number 4. We have negative 10 times the radical 4 minus 6x equals negative 80. That is our solution. We first have to divide by negative 10 to both sides because we have to get this radical all by itself before we get to take apart the radical. So this is negative 10 times, so we divide by negative 10 to both sides of the equation. Now that this radical is all by itself, we have the radical of 4 minus 6x, meaning we don't have anything on the right hand side of the radical or on the left hand side of the radical. We just have an equals 8. We could then get rid of that radical by squaring both sides of the equation. So we get 4 minus 6x equals 64. We then subtract 4 from both sides of the equal sign. We then divide by negative 6 to both sides of the equation. And then we get x equals negative 10. That is our solution. Number 5. Our problem is 9v squared plus 7 equals 88. That's our given. We first need to subtract 7 from both sides of the equation. And we get 9v squared equals 81. We then have to divide by both sides. Divide by 9 to both sides of that equal sign to get rid of that 9, and we get v all by itself. So we divide both sides by 9. 81 divided by 9 gets you 9. We have 9 times, and divide by 9s, they're going to cancel out, and we get v squared. So v squared equals 9. We then take the square root both sides of the equation, and we get v equals plus minus 3. Now remember, when you take the square root of 9, square root of 9 is 3, hence why we get a positive 3 as an answer. But we also have to consider the negative numbers, because negative 3 times negative 3 also gets you 9. So when we take the radical of 9, or the square root of 9, we get negative 3 also, because negative 3 times negative 3 gets you positive 9. That's why negative 3 is the solution. So my solutions are v equals positive 3 and v equals negative 3. They're both solutions. Problem number 6. We got 3p squared minus 9 equals 39. That's given. What we first need to do to get p all by itself, we have to add 9 to both sides of the equation. So then we have 3p squared equals 48, because 39 plus 9 gets you 48. We then have to divide by 3 to both sides of the equation. When we do that, times 3 and divide by 3, they cancel out, so you just get p squared on the left side. Then you divide by 3. 48 divided by 3 gets you 16. Then you take the square root of both sides, and you get p equals positive 4 and negative 4. So both are the answers there, positive 4 and negative 4. Next up is problem number 7. We get 1 minus n equals negative 5n plus 13. That's our given. We add 5n to both sides of the equation. So we get 1 plus 4n equals 13. We subtract 1 from both sides of the equation, and we get 4n equals 12. We then divide by 4 to both sides of the equation, because this is times 4, so we divide by 4. We do our inverse operations. And when we do that, we get n equals 3, and that is our solution. With number 8, we have 1 plus 2n minus 4 plus 12 equals 1 plus 7n minus 7n. That's our given. So first thing we do is combine like terms on the left side of the equation. The positive 1 and the negative 4, and the positive 12. Those three are like terms, so we combine them and we get 9. So we have 2n plus 9 equals 1 plus 7n minus 7n. We then combine like terms on the right-hand side of the equation. And positive 7 and negative 7, they cancel out. So we get 2n plus 9 equals 1. We then subtract 9 from both sides of the equation. 1 minus 9 gets you negative 8. Positive 9 and negative 9 cancel out, so we get 2n equals negative 8. We then divide by 2 to both sides of the equation, and we get n equals 4. That is our solution. Number 10, our goal is to find the product. All this means is we got to distribute out that 4. So our given problem is 4 times 5a plus 2. We distribute it out. 4 times 5a gets you 20a, because 4 times 5 gets you 20. And then 4 times 2 gets you 8. That's just the distributive property. That's our solution. Problem number 10. Same story. This is our problem. 4 times 6b minus 2. That's our given. We do the distributive property. 4 times 6 gets you 24. And then 4 times negative 2 gets you negative 8. That's our solution. 24b minus 8. Problem number 11. We're going to distribute once again. It's 3 times 7p squared minus 8p plus 6. That's our given. So 3 times 7 gets you 21p squared. 3 times the negative 8p gets you negative 24p. And then 3 times 6 gets you 18. That is our solution. Number 12. We're going to be doing the same thing. We're given 6 times 8 squared, 8r squared, minus 3r minus 2. We multiply it out. 6 times 8 gets you 48, so we have 48r squared. 6 times negative 3r gets you negative 18r. 6 times negative 2 gets you negative 12. So that is our solution, 48r squared minus 18r minus 12. Number 13. We're given 6r plus 5 times r minus 4. 6r times r gets you 6r squared. 6r times negative 4 gets you negative 24r. So we just distributed the first term right there. Next, we got to distribute the second term, meaning 5 times r, which gets you positive 5r, and 5 times negative 4, which gets you negative 20. We then combine like terms. Negative 24r plus 5r gets you negative 19r. And that's our solution. 6r squared minus 19r minus 20. Problem number 14. We're going to be doing the same process here. Our problem is 3x minus 4 times 6x plus 4. So we have 3x minus 4 times 6x plus 4. That's our given. We distribute the first term. 3x times 6x gets you 18x squared. 3x times 4 gets you 12x. And we just rewrite the second half of that problem. Then we got to distribute the second term, meaning negative 4 times 6x gets you negative 24x. Negative 4 times 4 gets you negative 16. We then combine like terms. Positive 12x minus 24x gets you minus 12x. And this is the solution. 18x squared minus 12x minus 16. Next problem. We're given 7x minus 3 times the trinomial of 3x squared minus 4x minus 5. We first distribute that negative 7x to everything. So negative 7x times 3x squared gets you 21x to the third. Because 1x multiplied by 2x's gets you a total of 3x's being multiplied to each other. 7x times negative 4x gets you negative 28x squared. Because x times x gets you x squared. 7x times negative 5 gets you negative 35x, because 7 times negative 5 gets you negative 35. And there's only one x involved, so you'd only put an x there. And I just rewrote the second half of that problem. And we're going to distribute that now. Negative 3 times 3x squared gets you negative 9x squared. Notice how I typed it in below, the other x squared, so it's easier to combine like terms later. Negative 3 times negative 4x gets you positive 12x. Negative 3 times negative 5 gets you positive 15. I then combine my like terms. Negative 28 minus 9 gets you negative 37. Negative 35x plus 12 gets you negative 23x. Carry down my 21x to the third, carry down my 15, and that's going to be my answer. The solution is 21x to the third minus 37x squared minus 23x plus 15. Next up is problem number 16. We have a binomial times a trinomial. 3x plus 3 times 6x squared minus 3x minus 5. What we first got to do is distribute. So 3x times 6x squared, well 3 times 6 gets you 18. X times x squared gets you x to the third. So 3x times 6x squared gets you 18x to the third. 3x times negative 3x gets you negative 9x squared. Because 3 times negative 3 gets you negative 9. X times x gets you x squared. 3x times negative 5 gets you negative 15x. I'm going to carry down the rest of this down below. We're going to distribute now this second term. 3 times 6x squared, or 3 times 6x squared down here, gets you 18x squared. 3 times negative 3x gets you negative 9x. And 3 times negative 5 gets you negative 15. We then combine like terms. Carry down the 18x to the third, because that has no like terms. Negative 9x squared plus 18x squared gets you 9x squared. Negative 15x minus 9x gets you negative 24x. Carry down our negative 15. That is our solution. Alright, for problem number 17, we have 6a equals WSD plus RT. What we first need to do is divide both sides of the equation by 6. And when we do that, we get A equals WSD plus RT divided by 6, as you see up here. That is our solution. Our goal is just to get A all by itself in this problem. Number 18. What we got to do, we got to combine our like terms first and get A all by itself. So we're given this 3A plus 2A equals 12WDS plus FG. We combine our like terms on the left hand side, so 3A plus 2A gets you 5A. We then divide by 5 to both sides of the equation. And we get A equals 12WDS plus FG divided by 5. Should be a nice little line below. I'll carry that down. Divided by 5. That's our solution right here. Now number 19. We have d equals xf minus xi. That's given to us up in the upper right hand corner here. Our goal is to get xf all by itself, so we add xi to both sides of the equation, the initial position there. That's what xi stands for in this problem. When we do that, we get d plus xi equals xf. Now xf is all by itself, so that's our solution. xf equals d plus xi. Remember, variables can be expressed in several ways, including xi, Greek letters, and xf. The initial velocity or final velocity, or in this case, it's the initial position and final position. Number 20. This is once again another one of those park problems that we have to try isolating. In this case, our goal is that we're going to isolate the initial angle. So we multiply by t to both sides of the equation. So we get Wt equals the final angle minus the initial angle. We subtract the final angle from both sides because our goal is to get the initial angle all by itself. When we do that, we get Wt minus OF equals negative OI, aka the initial angle. We then have to multiply both sides by -1. So we have a positive initial angle all by itself. We have an equation, a formula right here. So you have negative Wt plus the final angle equals the initial angle. We isolated the variable that we wanted to get by itself. Now this one is another challenging problem. Our goal is to find out, make an equation to solve for that brown area, that brown circle. So we're not including the white circle here. We want to find the area of that donut. So what we do, we have to remember, what is the area of a circle? Well, the area of a circle is pi times radius squared. And we're going to take the area of the big circle and subtract the area of the little circle. So what is it? Well, the area of the large circle, they tell us that the radius is 14 feet squared. So we put 14 in for the radius for the large circle. So 14 squared times pi equals a. Minus the small. Well, they don't give us a value for the small little guy, the radius for the small area. So we just write the formula that we do know. Area equals pi times radius squared, because we know that's the formula of the circle of the little guy. And we know if we take the big circle minus the little circle, the area of the big circle minus the area of the little circle, we'll be able to get the donut. So that's what I wrote here. Large minus the small. So 14 squared turns, I just rewrote it nice and pretty, so 14 squared pi minus r squared pi. I just got rid of the equals a's from both sides because we're only focusing on the equation. So now 14 squared is 196, so 196 pi minus r squared pi. What I did next is that I factored out the pi because we have a pi on both terms. So we have pi times 196 minus r squared. Hence why I got that equation. I changed the word minus into just a minus sign. So we have pi times 196 minus r squared. And that's our solution. That would be C. Last problem. We have to get x all by itself. So we have 7/2 times x squared equals 224. That's given to us. We then divide by 7/2 to both sides of the equation. So we get x squared equals 64. We then take the square root of 64 to both sides of the equation. So we get x equals 8. So that's positive 8. And it also equals negative 8. So x equals positive 8 and x equals negative 8. Those are our two solutions for x.